Hello everyone, welcome back to my YouTube channel. I am Bhumika from the Department of Computer Science and Engineering at Sri Venkateswara College of Engineering, Bengaluru. Today I am going to explain the topic of definitions of gradient, directional derivatives, curl and divergence. Gradient. The gradient is the inclination of a line. The gradient is often referred to as the slope of the line. The gradient or slope of the line inclined at an angle theta is equal to the tangent of the angle theta. Here we can see the two graphs of gradient. The gradient in the first graph, the gradient can be calculated geometrically for any 2 points x1, y1, 1, 1, x2, y2, 2, 2 on a line. The second graph represents slope is equal to y2 minus y1 divided by x2 minus x1. Further, the gradient is quantity which helps to understand the variation in one quantity with respect to another quantity. For a function f of x, the gradient is calculated from its first derivative differentiation of f of x. Summarizing the above sentences, we have m is equal to tan theta is equal to y2 minus y1 x2 minus x1 is equal to differentiation of f of x. Next, properties of gradient. The following properties of a gradient help to understand the orientation of the line. First, gradient can have a positive value or a negative value. The gradient of a horizontal line is 0 and hence the gradient of the x-axis is 0. The gradient of a vertical line is undefined and hence the gradient of the y-axis is undefined. The gradient of a curve at any point is equal to the gradient of its tangent at the point or the curve. The gradient of two parallel lines is equal to m1 is equal to m2. The product of the gradients of two perpendicular lines is minus 1. That is m1 into m1 is equal to minus 1. That is m1 into m2 is equal to minus 1. Second is directional derivatives. Directional derivatives. For a line drawn in an n-dimensional space, the gradient of the line with reference to a specific dimension is called its directional derivative. The concept of the partial derivative is helpful to find the directional derivative, and it is represented as del y by delta x. The concept of the partial derivative is helpful to find the directional derivative, and it is represented as delta y by delta x. Let us consider an equation y is equal to 5x plus 4z plus 3xz plus 11. This represents the equation of a line in a three-dimensional array. Here the partial derivative with reference to x gives the directional derivative in the direction of x-axis. In this expression, z is treated as a constant. Properties of directional derivative. The basic properties related to the directional derivative are discussed below. Suppose any two functions f and g are defined in a line of a point A and are differentiable at A. First one, rule for constant vector. Let k be a constant, then delta v of kf is equal to k delta vf. Rule for sum. The sum is distributive. Delta v of f plus g is equal to delta vf plus delta vg. Rule for product. This is also known as Liouville's rule. Delta v of fg is equal to g delta vf plus f delta vg. Fourth is chaining. It applies when f is differentiable at a. Curl. Curl in mathematics are differential operator that can be applied to a vector valued function or vector field in order to measure its degree of local spreading. It consists of a combination of the function's first partial derivatives. One of the more common forms for expressing it is curl V is equal to I of delta V3 divided by delta Y minus delta V2 divided by delta Z plus j of delta V1 divided by delta Z minus delta V3 divided by delta x plus k of delta V2 divided by delta Y minus delta V1 divided by delta x, in which V is the vector field of V1, V2, V3 and V1, V2, V3 are functions of the variables x, y and z, and I, j, k are unit vectors in the positive x, y and z directions respectively. In field mechanics, the curl of the field velocity field of, that is vector velocity field of the fluid itself, is called the vorticity or the rotation because it measures the field's degree of rotation around a given point. Divergence. Divergence in mathematics a differential operator applied to a three-dimensional vector valued function. The result is a function that describes a rate of change. The divergence of a vector v is given by divergence of a vector v in which v1, v2 and v3 are the vector components of v. Typically a velocity field of fluid flow in which v1, v2 and v3 are the vector components of v. Thank you all for watching my video. Please do like and subscribe to my YouTube channel.